Hey there, and welcome. Today we're not just learning math, we're building a powerful mental toolkit. We're going to get a handle on three huge ideas: ratios, proportions, and variations that'll honestly change the way you see and understand the world around you.
So, how do we actually make sense of this crazy world? It's a massive question, right? Well, a huge part of it, maybe more than you think, boils down to one simple thing: comparing stuff. Not just guessing, but making really accurate comparisons to understand all the hidden relationships around us. And here's the kicker: you're already doing this all the time, probably without even realizing.
I mean, think about it. You've got a recipe that serves 4, but 12 people are coming to your party. How do you figure out how much of everything you need? Yep, that's a comparison puzzle, right there.
Or how about this? You're at the grocery store staring at 2 boxes of cereal. One's bigger, but the other one's on sale. Which one is actually the better deal? To figure that out, you've got to compare the price to the amount you're getting. That's another comparison.
And hey, even just reading a map, it's all about this. That little scale in the corner that says 1 inch equals 10 miles. I mean, that's a super powerful comparison tool that turns a flat piece of paper into the real world. All right, so let's actually dive in and see how these tools really work under the hood.
Okay, so here's the plan. This is our roadmap for building out that toolkit. We're going to start with the most basic piece, the ratio. Then, we'll see how we can level up with proportions and put them to work. And we'll finish things off with a cool concept called variation before we step back and admire the whole set.
All right, first up, let's grab tool number 1, the ratio. This is the bedrock, the absolute foundation of everything we're going to talk about today. It's the simplest, most direct way you can compare any two things. Okay, the official definition here might sound a little, textbooky, but don't let it throw you. All it's really saying is that we're comparing two things of the same kind, using the same units. So we're comparing apples to apples, not apples to oranges. So for instance, say student A gets an 80 on a test and student B gets a 40. Okay, so the ratio is 80 to 40. But 80 to 40 is kind of clunky. To make it really useful, we simplify it down. Since 80 is double 40, the ratio simplifies to 2 to 1. Boom. Just like that, we can see that student A has scored exactly twice as high as student B. So much clearer, right?
Now, there is some lingo that goes along with ratios, but don't worry, it's pretty straightforward. In any ratio, say A to B, the first number, A, is the antecedent, and the second one, B, is the consequent. And knowing these just helps us talk about the different things we can do with ratios, like flip them to get an inverse ratio, or square them to get what's called a duplicate ratio. They're really just labels for different moves you can make.
Okay, you've got ratios down. Let's build on that and grab our second tool, the proportion. This is the big one. This is what you pull out when you realize that two different ratios are actually equal to each other. It's the secret to scaling things perfectly.
So, at its heart, a proportion is super simple. It's just an equation saying, hey, this ratio over here, it's exactly the same as that ratio over there. If the relationship between A and B is identical to the relationship between C and D, well then, they're in proportion. This is what's happening when you scale that recipe.
Now, check this out. When we write out a proportion like this, where the numbers sit is really important. The two on the outside, A and D, we call those the extremes. And the two on the inside, B and C, those are the means. And just remembering those two names, extremes on the outside, means on the inside, is the key to a really cool trick.
And here it is. This is what I call the magic rule of proportions, and it is a game changer. It says that the product of the extremes is always equal to the product of the means. If you multiply the two outside numbers together, you get the exact same answer as when you multiply the two inside numbers together. This one simple idea, that AD equals BC, is the key that unlocks the whole thing. It lets us find any missing piece of the puzzle.
Okay, enough talk. Let's put this thing to work. We're going to solve a couple of quick puzzles right now, just to show you how powerful this little rule really is for finding information that seems to be missing.
All right, puzzle number 1. What is the mean proportional between 0.08 and 0.18? Okay, mean proportional. Sounds complicated, right? It's not. It's just a fancy way of asking for the missing middle number in a proportion where the two means are the same. So think of it like this. 0.08 is to something as that same something is to 0.18. We're looking for that mystery number in the middle.
And the answer is 0.12. So how did we get that? Well, we just use our magic rule. The product of the means, that's our mystery number times itself, or y squared,
has to equal the product of the extremes. So we just multiply 0.08 by 0.18, which gives us 0.0144. Then we take the square root of that, and bam, 0.12. The rule just works.
Okay, ready for another one? Let's do it. What's the fourth proportional to 4, 9, and 12? Again, fancy words for a simple question. This is just asking 4 is to 9 as 12 is to what? We're looking for that last missing number in the sequence.
The answer is 27. And how do we get it? You guessed it, the magic rule. The outside numbers multiplied together, that's 4 times our mystery number, has to equal the inside numbers multiplied together. That's 9 times 12. So 9 times 12 is 108. What times 4 equals 108? We just divide 108 by 4, and there it is, 27. See how easy that is? That rule is your secret weapon. All right, time for our third and final tool in the kit, and this one is all about things that change, variation. See, ratios and proportions are awesome for things that are sitting still. But variation, that's what we use to describe relationships that are dynamic, where things are moving and changing together.
And there are really two main flavors of this you got to know. First up is direct variation. This is the easy one. When one thing goes up, the other thing goes up with it. The classic example, the more hours you work, the more money you earn. Simple. And the flip side is inverse variation. You can probably guess this one. As one thing goes up, the other goes down. Think about driving. The faster your speed, the less time it takes to get there. They move in opposite directions.
And that's it. Just like that, we've put together this incredibly powerful 3-part toolkit for looking at the world. So let's just do a quick final check of our new analytical superpowers.
So let's lay it all out one last time. Tool number 1, the ratio. That's for your basic side-by-side comparison of two things. Tool number 2, the proportion. This is your go-to for scaling things or finding a missing number when you know two ratios are equal. And finally, tool number 3, variation. You pull this out when you want to describe how two things change with each other, either together or in opposite directions.
So you are now officially equipped with the fundamental tools of comparison. The world is absolutely full of these hidden relationships, these patterns just waiting for someone to notice them. Now that you have the toolkit, what are you going to look at first? What will you compare?